So the next question is that I'm given two strings. Let's say string number 1 and string number 2. String number 1 is, let's say, cat, and string number 2 is, let's say, car. Right? Have you done the added distance problem?
No.
Faguni?
No.
So two strings are given. We have to find out what is the distance between these two strings, right? When I say distance between these two strings, I mean how many operations are required using which I can make S1 equal to S2, right? Now, what are the operations that I can perform? I can perform one of the three operations. The first operation is I can insert a character. I can insert any character at any position in the string, right? So I can insert any character ch in the at any position in the string, right? So this is position, POS. Second operation is update. So update means I can change any character to new character. So this is my new character, and this will change the character which exists at position POS to the new character, right? And third operation is delete a character. Let's say I am given a string and I am given integer position. So this will delete the character at position P, right? So if I want to make S1 equal to S2, I can just update the character T to R and both of them will become same.
Yes.
So what I say is that the added distance between these two strings is equal to 1, because I need to change at least one character of string S1 to make it equal to string S2. Does it make sense?
Yes.
Faguni, is the question clear?
Yeah. Can I add the character in both strings? Like, can I add R in T and T in R? The second one.
If you add R here and if you add T here, then these are two operations.
No. Can I make both of them as CA or T? Like, can I add one character in both?
So adding one character in both means is are we allowed to change both the strings? So that will make the question little more complex. Let's say the second string is constant and we are allowed to change the first string.
Okay.
Right. So I tell you why this is coming, where this is coming from, right? Let us say you type CAX. So if you type if you type CAX in your MS Word document, in your Word document, what happens is that there is a red line below it, right?
Yes.
And when you hover the mouse on CAX, it will suggest you that maybe you mean CAR, or maybe you mean CAP or CAT, right? Right? So it is suggesting you the strings which are at a minimum distance from this string. Does it make sense?
Yes.
Yes.
So it does not suggest you cartoon, right? That maybe you mean cartoon because you are typing CAX, right? Because cartoon is very far away from this CAX, right?
Right.
So if I have to find the added distance between these two, so first I'll have to remove this. First I'll have to update this X to R, and then I have to insert these three characters. So the added distance between cartoon and CAX is 3, right? But the added distance between CAX and these three strings is 1. So it is first it is finding out that this word is not recognized. So this word is not a valid word which is present in the dictionary. So maybe it will use try for that. and then it will suggest the strings which are at a minimum added distance from this string and which are present in the dictionary. Does it make sense?
Yes.
So let's say I have two strings, Saturday and Sunday. What is the added distance between these two strings? So day remains the same, U is also present, S remains the same. So maybe we can delete these two characters. So delete operation, and we can update this R with N. Right?
Yes.
Right, Faguni? So we use three operations. First operation is delete character A. Second operation is delete character T. And third operation is update character R with N. And then Saturday will become equal to Sunday. Right? So how can you solve it? Faguni is there. Alright, so how will you solve it? Chetan?
Do I have to check the sum of the ASCIIs and then subtract
Do I have to check what?
the ASCII character for each word, for each?
So whenever you compare two characters, it is actually comparing the ASCII code only, right? So how do I know that A is equal to A? So internally I am comparing 65 with 65 because both the values are same. So it means the characters are same, right? So you compare the characters or you compare the ASCII code. It's actually from semantic point of view they are going to be same.
Iterate the first string character by character, put it in a hash map,
Mm-hmm.
and then iterate the second string,
Mm-hmm.
and then compare it with the hash map against the hash map.
So your solution is similar to. So what you are suggesting is. So what you are suggesting is very similar to finding the union of characters or finding the characters which are present in string 2 which are also present in string 1, right? Let us say the first string is CAR and the second string is RCA. In this case, both the strings have same characters, but their added distance is not 0, right? Faguni,
Yes.
you understand what I want to say,
Yes.
right? So, I think you guys are probably not thinking recursively, right? So, what do we have? We have these two strings, Saturday and Sunday, right? So, I want to reduce the problem. So, initially, what do I have? Initially, I have n characters here and I have m characters here, right? Right?
Yes.
If the two characters are same, s is equal to s. Can I say that I just need to find the added distance between n minus 1 characters of the first string and m minus 1 characters of the second string? Chetan?
Yes.
Right? So let me just write it somewhere. integer edit distance, and I have two strings, character pointer s1 and character pointer s2. For strings, we don't need to pass the length of the string, but let's say I am passing the length also, just for the sake of being more clear, having more clarity, right? Integer n. So the first condition that we are putting is that if s1 first character of s1 is equal to first character of s2, then find the edit distance between strings starting from s1 plus 1 and s2 plus 1, the first string having n minus 1 characters and the second string having n minus 1 characters, right?
Yes.
Chetan?
Yes.
Faguni?
Yes.
Yes.
Right, so we are at least moving forward. And what will be the terminating condition? Can I say that if m is equal to 0, if m is equal to 0 means there are no characters in the second string. If there are no characters in the second string, then we have to delete all the characters from the first string to make it equal to the second string.
Yes.
So it means that how many operations are required? N operations are required.
Yes.
So can I say that just return n?
Yes.
Faguni?
Yes.
Similarly, I can say that if n is equal to 0, it means that number of characters in the first string is 0. There are no characters in the first string. But there are certain characters. There are some characters in the second string. So I need to insert all of those characters in the first string to make it equal to the second string.
Right.
Right. So what should I return? Should I say that return m? Right? Chetan?
Yes.
And one of the terminating condition which is actually already covered is that if both of them are 0, if both of them are 0, then we will just return 0. Right? But this condition is already covered here. Because both of them 0 means m is equal to 0, so it will return n. If n is 0, it will return 0. Right?
Yes.
So this condition is already covered, so I am just removing it. Alright. Now the problem comes when the two characters are not same. Right? Now this a and u are not same. What should happen now? A and u are not same. So there are three possibilities. Either I will delete this character a.
Minimum of.
Exactly. So the first possibility is that delete the character a. Second possibility is that update the character a with u. And third possibility is that insert a character u in between s and a. So insert a character u before the first character of first string. I cannot have more than these three possibilities.
Yes.
Yes.
Right? So let's say let's say if I am deleting character a, what do I need to find now? If I am deleting character a, then I am left with n minus 1 characters here, and I am left with m characters here.
Yes.
Faguni?
Yes.
So I need to find the edit distance. So this is for deleting the characters. Delete operation. So if I delete the characters, then because the character is deleted from S1, so length of S1 is reduced, but length of S2 remains the same. Does it make sense?
Yes.
If I update the character means that A becomes equal to U. If A becomes equal to U, then I can just move forward, right? So there are how many characters? N minus 1 characters left here, and m minus 1 characters left here, right?
Yes.
So y is equal to the same operation that I was doing earlier here, right? Now,
Yes.
now because after updation, the first character becomes equal to the first character of the two strings becomes equal. So I'll just move forward, right? Right, Chetan?
Yes.
The difference between these is that in this case, I am not performing any operation, but in this case, I am performing an update operation.
Yes.
And last one is delete the character, right? Sorry, last one is insert the character. So if I insert u here, then this new character u will become equal to the already the current character of second string u. So I'll move the second string forward, but the first string will have the previous n characters.
Yes.
Fagni?
Yes.
So basically the insert operation is going to be, let's say this is z, so z is equal to, this is my insert operation. So n remains same. First string still has n characters and the second string has this. And what should I do? Should I just return the minimum of these?
Yes.
Anything which is left? So in all the three cases, Chetan, in all the three cases, can I say that I have performed one operation?
Yes. Yes.
Right? Here I have performed the delete operation, here I have performed the update operation, and here I have performed the insert operation.
Yeah.
I am not counting that one,
Yes.
right? So should I just say that minimum of x comma y comma z plus 1 because one operation I have already performed,
Mm.
right? Faguni?
Yes.
So that's it. We are done. Right? So let me repeat what I have said yesterday. Basically, what I'm saying is that if you focus on recursion, then solving a dynamic programming problem becomes easier. Right? Now let us look at now this is obviously a recursive solution. The complexity of this problem is O of 3 raised to the power n because we are calling the function 3 times inside the same function. Right? So obviously this is exponential time complexity. So we need to optimize this, and we will optimize it, right? Now let us look at the dynamic programming solution, right? So the dynamic programming solution, usually we have an array or a matrix depending on number of variables. Here we have two variables, so let's put Saturday on the x-axis and Sunday on the y-axis, right? 3 3 6 7 8 2. So let me just put let me just insert a so I'm using a two-dimensional matrix of order n plus 1 cross m plus 1, right? And I'm putting a Saturday here, and I'm putting a Sunday here. The first row is for null and the first column is also for null, right? Let me tell you what do I mean. I mean that any cell ij, let's say this cell represents the added distance between first string SATUR and second string SUND. Does it make sense?
Yes.
Right? So any cell ij represents the added distance between first I characters of first string and first j characters of second string. right? Right?
Yes.
Actually, this is starting from 0. So 0, 0 actually represents the length, the array distance between 0 characters of first string and 0 characters of second string. So that's why I'm putting a null. Null means that first string is not considered at all, right?
Yes.
Faguni, you are following?
Yes.
All right. Can I say that after we populate this matrix, the answer will be in the last cell? Because last cell represents the array distance between complete first string and complete second string,
Yes.
right? All right. So let's start populating this. If the first string is empty and second string is also empty, what will be the array distance between the two strings?
0.
0. So here we will have 0, right? So let me just put it. So let's say the name of this matrix is ARR. So ARR of 0, comma 0 is equal to 0. What will be the array distance? What will be the array distance if the first string is empty but the second string has one character S?
1.
1. What will be the array distance if the first string is empty and second string has two characters SU?
2.
2, and so on. 3, 4, 5, and 6, right? Right, Faguni?
Yes.
And similarly for the first row, if the second string is empty and first string has one character, then the array distance will be 1, right? Because we need to remove this character, right?
Yes.
And similarly, this is 2, 3, 4, 5, 6, 7, 8. So these two conditions are nothing but the terminating conditions of our recursion, right? If if the first string is empty, then array distance is equal to length of the second string, and if the second string is empty, then array distance is equal to length of the first string, right?
Yes.
Faguni?
Yes.
Right? So I'll put a for loop here. Let's say we put a for loop, right? So this you can do. For I is equal to 1, I is less than equal to n, I plus plus, and ARR of 0, I is equal to I, right? Similarly, we have this. I is less than equal to m, ARR of I 0 is equal to I, right? So we have populated the first row and the first column. Now we just need to start from this cell 1, 1 and go up to the last cell mn, right? So for I is equal to 0, I is less than equal to m. The length of the first string is n, so we'll go like this. So we are going column wise. We are going row wise. Right? And we will use the same logic which we have used in the recursion, right? So the logic we have used in the recursion is that we will compare the corresponding characters. So in this case, we will compare S and S. If they are same, then length of then array distance is equal to, so I need to put a return here. So if they are same, S and S is same, then array distance is equal to the array distance between the strings when the first character of the first string, when the first character of the two strings are removed, right?
Yes.
So I'll compare the ijth character of the two strings, right? So if str of I minus 1 is equal to, let's say this is not str, this is s1. If the ith character of first string is equal to the jth character of the second string, then just populate the value from the matrix from the diagonally opposite cell, right? Does it make sense? Chetan?
Yes. Yes.
Otherwise, what should we do? Otherwise, we will consider the three possibilities. First possibility is when you remove the first character of the first string. Second possibility is when you update the first character of the first string. And third possibility is when you insert the first character of the second string before the first character of the first string. Right? So in all of these three possibilities, what I am doing is I am either considering n minus 1 m, or I am considering n minus 1 m minus 1, or I am considering n m minus 1, which means that I am considering either this 1 or this 1 or this 0, depending on which of them is minimum.
Yes.
Right? So I'll be considering the minimum of these three plus 1, because one operation I have already performed. Right, Faguni?
Yes.
So can I say that otherwise ARR of ij is equal to minimum of ARR of ij minus 1, ARR of I minus 1j, and ARR of I minus 1 j minus 1. I minus 1 j minus 1 plus 1 because one operation I have already performed. Does it make sense?
Yes.
Faguni?
Yes.
All right, great. So should we move forward? Right? Let's see how this matrix is getting populated. Right? So just quickly, if we can do this. So this will be 0 plus 1, 1. Right? Then A and S are not equal, so it will be 1 plus 1, 2. Then T and S are also not equal, so it will be 2 plus 1, 3. Then S and U are not equal, so it will be 3 plus 1, 4. Similarly, 4 plus 1, 5. 5 plus 1, 6. 6 plus 1, 7. Sorry.
This should be 0. S and S. Because there is no operation required, right?
Yeah, so for S and S, it will be 0. Right. For S and S, it will be 0. Because S and S are same, so it will be 0. Then S and A are not same, so it will be 0 plus 1, 1. Then S and T are not same, so minimum of 1, 2 and 3 is 1. So it will be 1 plus 1, 2. Similarly, 3, 4, 5, 6 and 7, right?
Yes.
Right. Then we populate this U, then we compare this U and S. U and S are not same, so we'll find the minimum and add 1 to it. So 0 plus 1, 1. Right? Then again U and A are not same, so it will be 0 plus 1, 1. So this 1 actually indicates that the added distance between SA and SU is 1. Right?
Yes.
Which makes sense also. The added distance between SA and SU is 1 only. Right, Faguni?
Yes.
Similarly, U and T are not same, so it will be 1 plus 1, 2. Right? U and U are same, so we'll just copy the diagonal value. U and U are same, so it will be 2 here. Right? Then U and R are not same, so not same means 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. And 5 plus 1, 6. Does it make sense?
Yes.
Right? Now compare N. So N is not equal to S, so it will be 2. N is not equal to A, so 2. N is not equal to T, so 2, coming from diagonal. N is not equal to U, so 3. N is not equal to R, so 3. N is not equal to D, so 4. N is not equal to A, so 5. And N is not equal to this, so 6. Does it make sense?
Yes.
Alright, now comes D. D and S are not same, so it will be 2 plus 1, 3. it will be 2 plus 1, 3. Then D and A are also not same, so 2 plus 1, 3 again. D and T are also not same, so 2 plus 1, 3 again. D and U are also not same, so 2 plus 1, 3 again. Right? Right?
Yes.
Then D and R are also not same, so 3 plus 1, 4. And D and D are same. So same means that we will just copy this here, so 3. So what we mean here is that the added distance between S, A, T, U, R and S, U, N, D is 4. But the added distance between S, A, T, U, R, D and S, U, N, D is 3. Right? So we'll just D and D, S and S. So we'll update the 3 characters U and U. We will remove these 2 characters and update R to N. Right?
Yes.
All right. D and A are not same, so it will be 3 plus 1, 4 and 4 plus 1, 5. Now let's populate this second last array, the second last row. So it will be 4, 4, 4, then this will be 3, A and T, so it will be 4, and A and U, so 4, A and R, so 4, A and D, so 4, A and A means it will be 3 only, and A and Y means 4. Now let's populate the last row. Last row, Y is not equal to any other character except for this last character. So we'll just say 5, 4, 4, 5, 5, 5, then 4, and finally 3. Right? Right, Chetan?
Yes.
So the added distance between the 2 characters is equal to 3. Between the 2 strings is equal to 3. Does it make sense?
Yes.
Faguni?
Yes.
Right? And and the order of this matrix is equal to m plus 1 cross n plus 1. So we are able to compute the added distance between 2 strings in the order of m is to n. Right?
Yes.
So this is a huge improvement over the O of 3 raised to power n exponential time complexity.